Hello and welcome to this PIR live event webinar brought to you by Partners in Research Canada. My name is Stacey Joyce and I will be your host. Please remember, if you're joining us live, that you can ask questions anytime throughout the webinar by finding your way to the chat button in the top left corner of your Zoom window and making sure that you change the to field so that it includes all panelists and attendees. That way everyone who's joining us today will be able to see who is asking what questions from across the country. We also have a guest expert today, and our guest expert is Dr. Jeff Orchard from the University of Waterloo. He is an associate professor in the Sheridan School of Computer Science. He's also cross-appointed to two other departments in biology and applied mathematics. He is a core member of the Center for Theoretical Neuroscience, and he is the Director of Computational Mathematics as of January 2018, so that's starting up soon. So lots of fancy big words and credentials, but ultimately he is a pretty relatable real guy who's going to show you a bit about why he thinks coding is so fun and how you can get started. So I am going to, without further ado, turn it over to Dr. Jeff Orchard. Thanks so much for joining us today.
Thank you, it's my pleasure. And I got into computer science because I really like programming. So I think there's a lot of fun that can be had. And I want to show you, you kids, some of the things that you can do to learn how to program. And it's kind of funny sometimes because it's hard to tell if you're playing a game or you're coding. Now, let me show you that. So let me go ahead and share my screen here. I'm going to show you something called Lightbot, which is a program that was actually created by someone here at the University of Waterloo, but that's not relevant. So this is Lightbot. You can play it online. You can get an hour of code iPod or iPhone app or iPad app. So let me just show you quickly a little bit of it. I've already started some here. I'm going to go through it quickly just to give you a flavor. So let me start at the very beginning here. So the idea is to get this Lightbot, this robot, to move forward. Let me click past these. You can read these later when you're doing it yourself, but I can describe it. The idea is to get this robot to move forward and then land on this dark blue square and turn the light on. So you can see the very first one, it's telling me I've got to move forward. Now, as I choose these tiles, it creates this program up here on the right, the main program. So I've got to move forward tile. The robot has to move forward again. And then I'll show you. So move forward, there it is, and then I have to turn the light on. So here's my program. Move forward, turn light on. So let me go back and try it. Move forward, light on. Okay, we did it. This is the program that tells the robot how to turn that light on. So let's try a different one. There are lots of these. They're like games, they're like little puzzles. So in this one, I need the robot. Okay, let me click on those to get rid of them. You can read them later. The robot has to move forward, turn left, forward, turn left, forward, turn the light on. Okay, so let's do that. Forward, turn left, forward, turn left. Now, if we want to see where we are, we can just go ahead and say go, and it'll go through this program, through the different tiles. So this is where we are. We need to add another forward, and then turn the light on. So here's the program that tells my robot what to do. So if I say go, forward, turn left, forward, turn left, forward, turn left. So there are lots and lots of these puzzles. It really is like playing a game. My kids love to play this. So, but without realizing it, you're actually learning how to code. Let me see if I can show you one more that's a little more complicated. Let me do this one. Okay. Now this is showing that one of the main things about coding is that there are patterns that come up, and what you want to do is recognize that pattern and use it over and over again. So listen to what I'm saying. Here's the pattern. Listen for the pattern as I describe how this robot moves through this maze and gets to that dark blue spot. Listen for the pattern. Forward, turn left, forward, turn right. Forward, turn left, forward, turn right, forward, turn left, forward, turn right, forward, turn left, forward. So I did a lot of repetition there. So what I'm going to do is that repetition, I'm going to put in this procedure here. It was forward, turn left, forward, turn right. So now that's the pattern that it repeats over and over again. Now I can use that pattern, get my robot to do that pattern by putting P1 here. P1 means do the procedure in procedure 1. So if I ask it to go, it does the procedure, but I need to do it more than once, so I can make it do it again and again and again. Let's see, where will I be at the end of that? I can speed up here. Okay, and then at the end, I just have to click the light. So if I tried to do this entire maze just by putting tiles up in the main program, I'd run out of space. So if this Lightbot forces you to create these little procedures. So this is a really fun game that teaches how to code. So let me get out of full screen here. And I want to show you, very quickly show you a different game. So I hope you can see this screen. This is, yeah, okay. This is something called Scratch, and it's from MIT. You go to scratch.mit.edu. There are lots of links to it. I'd like to just show you quickly how to produce a game in Scratch. Okay, so this is a little bit more advanced. It's helpful if you can read, but let me just show you how quickly you can make a little game. So here's my cat, and it's what we call a sprite. And over here on the right will be the little tiles and blocks that I drag that control what the cat does. So let me say, for example, I need something to start it. So I'll put this starting block here. So now when I click this green flag, it's going to start here and start doing the blocks as it goes down. So let me just do a simple one. Move 10 steps. So watch the cat now when I click the green flag. It moves forward. But there are lots of different blocks here, so I can add these loops. So now this repeat loop will do everything inside this bracket 10 times, or as many times as I want it to. So let me change it to 4. So now when I click the green thing, it's going to move forward 10 steps 4 times. And in fact, I can replace that with a forever loop. So it's all just dragging and dropping these little blocks. So they would just keep moving forward. I can add another character. Let me add, let's see. Oh, I know, a mouse. There's a mouse in here somewhere. There we go. I'm going to add the mouse. So now this is a separate character which has separate programs that control it. So I'm going to make the mouse be controlled by, make it follow my cursor, my mouse cursor. Sounds appropriate. So I'm going to add a forever loop, repeat forever, and I want it to go to the mouse pointer. I better stop the cat from doing that. So now when I say go, the mouse just follows my pointer. It's kind of neat. So let's make the cat chase the mouse. So this is the mouse's program. Let me go back to the cat. So now I can add a forever loop. Whoops, forever. And what I want the cat to do is point towards the mouse, which is my mouse. So you can see there are lots of different things here. You can look through these later on when you're playing with them. The more you play with it, the more opportunity and more different fun things you can find to do. And move forward, let's say, 3 spots. So now when I say go, the cat is chasing the mouse. So this is a game that I made in 4 minutes, 3 minutes. And so you can change the backgrounds by choosing different stages. And so let me show you a game that I made earlier. Excuse me. Go to my stuff. This one's called Speedy Beetle. and you can all access it. It's a little game that it took me about maybe half an hour to write. So it's just this beetle. If I press the space bar, it starts there. Then when I press the space bar again, it's following my cursor kind of slowly. My computer's working hard because I'm doing this video chat thing. Normally this would go a bit faster. But the idea is to get it to go through this maze and not touch the black stuff. And then you want to do it as quickly as possible. And every time it touches the black, you get a penalty, a time penalty. So everyone can try this and they can look at the code and then change it, make a copy of it, do whatever you want. A lot of fun. So those are the two things I wanted to show you. And I'd love to see what games you guys can make up. Any questions?
A challenge already for all of our primary students out there today. We also have a question already. We mentioned that that you work in theoretical neuroscience, and we have a question from Ms. King's class wondering what is the connection between coding and neuroscience?
Well, we simulate brain circuits and we simulate neural networks on computers. So I do a lot of writing programs. That's kind of what I do as my job. Of course, there are lots of different programs you can write for different purposes. Turns out I like to write programs that try to figure out how the brain works, but there are lots of other programs that people write as well. Video games, Facebook, Instagram, all these things are programs. So people wrote those, they coded them.
Right. And we also have another question from Ms. King's class, wondering when you learned how to code.
I learned, let's see, in high school, I guess. But of course, when I was young, computers weren't in every house. They were quite rare. So I learned in high school. My dad brought home a computer one day. He's a high school teacher, or was a high school teacher. He brought home an old computer called the Commodore 64 and just left it on the desk, and I started playing with it. And very quickly I realized, wow, this is really cool. You can do a lot of really interesting things really quickly. I mean, now you can do far more interesting things with far less time. So really how do you say that? I don't know, I'm looking for a phrase, but it's just a lot easier to get started in coding right now.
There you go. So the big push to get started in coding now too, I think when you first started, you must have been one of very few people who were even trying to code anything.
Yeah, it wasn't clear what it was all going to be about, but now it's pretty clear that it's an extremely useful skill to have.
And our next question now is from the grade 3s at Auburn Bay, wondering if you have any experience with dot and dash.
I don't. I've never heard of dot and dash.
So there you go, an opportunity to those grade 3s to let Dr. Orchard know what dot and dash is. I have a feeling some other students who are joining us today might have played a bit with dot and dash. Another question coming in from Mr. Francia's class, wondering, sometimes when they are solving coding puzzles, they get frustrated. They're wondering if you have any advice for them.
I can relate to that. It can be frustrating coding, but just like anything that's worth doing, it can be difficult. Advice. Sometimes it's good to walk away and just stop doing it for a while. And then when I come back to it, I can approach it with a fresh mind. Sometimes all I need is to be in a quiet place somewhere and focus on what I'm trying to solve. It can be difficult when you're in front of the computer and you're trying a whole bunch of different things. Sometimes you need to remove yourself from that and instead just sit quietly and think about it. That would be my advice.
A little bit of a break then and going back to it.
Yeah.
Next, we have a question from Sundridge Centennial Public School, wondering why you like coding and how are phones and tablets coded?
I feel I've always felt like coding is sort of like Lego. You're building something. It's like you're building a toy, if you like, or a tool. And in Lego, you build things, and after you're done building it, you can play with it. But I always found the building part more interesting than the playing part. So that's what it feels like to me. It feels like building something out of Lego, building a toy. The question was how iPods or iPads and tablets were programmed.
You got it.
Everything's kind of programmed the same way. It's all about putting the commands in order. You have an idea of what you want the device to do, what program you want, what function you want it to do, and you start putting down the commands, just like I showed you in Scratch. You just lay out the commands that get the device to do what you want. So they're all programming like, I mean, really, once you know how to program once, you know how to program everything. There are little variations on different types of coding, but for the most part, it's all pretty much the same. So you learn how to code, and then lots of different languages, lots of different devices become available for you for coding.
Wonderful. And we had a quick question here about whether or not you created Scratch. I believe you said that was created at MIT. But we also have a question from Kira in Guelph wondering what was the first thing you ever coded and how old were you?
First, to think about the Scratch. No, I did not create Scratch. It was created by some very smart people at MIT. But lots of different groups are now creating these coding game apps interfaces. So, so the very first program I wrote, I used to have, I used to play a role-playing game, and I got tired of, it's called Dungeons and Dragons. Okay, really old game. You would roll dice, but I got tired of playing Dungeons and Dragons, and instead I would roll dice to make my characters play tennis against each other. I made a little tennis league. I got tired of rolling dice, so I wrote a program that would make them play tennis against each other. It was just numbers. There was no graphics, no like tennis rackets swinging or characters running around. It was just the algorithm of what I would do to roll the dice to see who would win. I implemented that in a program, and I loved it. That was a lot of fun.
So the very first thing was rolling dice. Interesting. And you're outed now. You were a D&D fan. Yes. All the teachers know what you're talking about. I'm not sure about the students yet, but
or those Stranger Things might know also.
Okay. Well, next we have a couple of broader questions, but before I get to those, I'm going to come back to our grade 3s at Auburn Bay who are asking about Dash and Dot. They would like you to know that they are robots that they program using an app on their iPads called Blocky. So little robots that they're programming at school called Dash and Dot.
That sounds like a lot of fun. Cool. Mm-hmm. Way to go.
And our next question is more broad. So we've got a question coming in from Mr. Francia's class about what kinds of skills will they learn by coding?
I mean, there's nothing magical about coding. It's not, it's problem solving, the type of things you problem solve every day. I guess some of the specific skills for coding is thinking carefully about what's going to happen. So the one thing about a computer is it does exactly what you tell it to do. And sometimes what you mean is not what you say. So sometimes I write a program and it looks fine to me. I run it and it does the wrong thing. So you have to kind of go through carefully and look at what you asked it to do and make sure that that's what you actually want it to do. So thinking carefully about kind of stepping through your process, your thought process is one skill. I think it also develops kind of mathematical skills. There's a lot in common between mathematics and programming. It's the same sort of careful sort of deductive way of thinking.
Right. And next we have a couple questions about coding languages. So we have a comment from one of our attendees here who knows that one of the Scratch inventors is apparently Brian Silverman, who is a Canadian living in Montreal. So one of the inventors is Canadian. And then we have questions about coding languages. How many are there? And are you planning on making your own coding program or language?
There are many, many. I don't know how many there are. Java, Python, C++, Ada, COBOL, and I mean, there are a lot of new languages that I've never heard of that probably some of the people in the audience have heard of. So I'm not planning to make my own language. It sounds like a fun thing to do. That's not my particular focus in computer science. But I know that, I mean, people that created Scratch and all these other languages, I know I had a student one time that I worked with a little bit who was interested in creating a learn how to code language. So I really don't know how many languages there are. You basically, it's kind of a moving target. New languages come about and sort of take over for a little while, and then something else new comes along that everyone gets excited about. And so there's a constant sort of churn in the market, which keeps things really interesting. Things are always sort of progressing, I guess.
I'm just checking the time here. We still have time for more questions, so keep them coming. We have a question now from our grade 2 class at Mary Shad, wondering if every game that's created is created by coding.
Every computer game is, yeah. I mean, like a board game, obviously not. But yeah, every computer game is coded. That's the language of how you get a machine like a computer game console or a computer or an iPhone or an iPad or whatever. That's the language of how you get it to do what you want it to do, like make a game.
Right. And a question now from Ms. King's class, wondering what is on the whiteboard behind you and does it have to do with coding?
This is a wall hanging from some of my academic colleagues in China. This is to do with my research, neural network stuff and coding. Yeah, it's mathematics and coding put together.
So is there a similarity in how our brains work and how we code a computer to do a function or to create a game?
They're kind of different. The way our brains work is a bit different. There's a lot of really fascinating research and new developments coming out these days with computer programs that simulate how the brain works. So this is the basis of artificial intelligence that's kind of making the big headlines right now, like AlphaGo beating the best person in the world in the game of Go, and the computer beating the person in Jeopardy. So a lot of excitement going on. The type of programming you do in Scratch is probably quite different than what goes on in your brain.
Right. And Evan in Guelph is wondering if you like being a professor. I
do. It's a pretty good job. I think I would have been happy doing lots of different jobs. I think I used to be a mathematician. I went to university for math, but then I got this opportunity to go into computer science, and I thought, I kind of thought about it for a while, then I looked at what I'd be studying, and it seems so much more exciting to me. So I'm so glad I made the jump into computer science. But there are lots of jobs I'd be happy in. I think as long as I was coding, I would be happy.
And that brings me right to the next question I was going to ask you, also from Guelph. What kind of jobs is coding needed for?
I mean, computer coding is used in pretty much every field, every area, in film industry, in like social networking, computer operating systems, the gaming industry, even in education. Like right now, we're using software so that we can talk to each other and see each other. It's used in every industry. So what I like to say is whatever you're interested in, there is a way to get into that industry as a coding person. There is someone in that industry who needs coding done. So everything, as far as I'm concerned, everything.
I find it amazing, even if you are not the primary person who is coding within whatever field you're in, having an understanding of how that works is really, really useful to even be part of a team now in any field. So
That's right. There are lots of different levels of coding. There are people who get really down and detailed in the machine, and then there are people who do coding that's more high level, that they just sort of, just like I did in Scratch, kind of move blocks around and get the sort of the whole thing doing what they want it to do. Lots of different levels to get into coding.
Right. And we have a question now from Laura, who's wondering what type of coding is the easiest to learn? And what is your advice for someone who is learning to code? So just starting out, where's a good place to start?
I think the two things I showed you are good. Lightbot's really good, which I showed you. I showed you Scratch, which is a slightly more advanced. There's a slightly simpler version that runs on iPad or an Android device called Scratch Junior. Now it's a little bit simpler. You don't have to be able to read as much. You can kind of drag these little tiles and put them together. It can't do as much, but it's a better introduction for those who are just maybe like emergent readers and that sort of thing. But I would say in terms of getting your hands really into it and getting messy and doing lots of fun things, I would say Scratch is a great language to start with.
And is coding a website very different than coding a game like this or a function? We've got a question coming in from Kayla.
It can be different, yes. What Scratch is what we call event-based programming. So you're programming the behavior of one sprite, and it reacts to different things that are going on. You create little programs to tell it how to react to different things, like if it touches another character, or if it reaches the end of the box, or if it hears hi from another character. Web-based programming, it's the same idea that you sort of have a bunch of commands and you list them and you have special codes that make the page look the way you want it to look. But it's not event-based, so it's a slightly different way of thinking about programming.
Right. And now a question from our grade 3s at Auburn Bay, wondering what your preference is for a language for coding. Do you like Java or Python or Scratch?
So I should say I don't know a lot of languages. There are lots and lots of great languages. I personally, in my field, in my research area, people use Python a lot. But, you know, it varies. Lots of great languages.
Interesting. So I guess if you want to know, you just find a few and try them out and see which one works best for you. We also have a question from Ms. Hornet's class, wondering at what age can you code? Is there a minimum age requirement, do you think?
No, I don't think so. You know, it's just like anything, like looking at books or playing with Lego. Is there an age when you should, well, I was gonna say, is there a minimum age where you should, is there an age where you shouldn't be doing Lego if you're too young, for example? Yes, because you might eat the blocks if you're a toddler or something. But once you're past that, anyone can do Lego. I play Lego with my son sometimes. So coding is like Lego. As long as you can use the mouse and control, you know, push buttons on the keyboard, something like Scratch or Lightbot or Scratch Junior will help you get started.
Right. And I know we're running out of time here, so perhaps now is a good time to just say, if we have students who are really interested in checking this out and giving it a try, do you have any last thoughts or advice for them?
Have fun. Make a game and challenge your friends to play it. Make a game in Scratch and challenge your friends to play it. You can do that.
That sounds like a great day at school to me. All right, well, that is all the time we have. Thank you so much, Dr. Orchard, for joining us, showing us a few programs to start out with and answering all the questions our students had today.
It was fun. Thank you very much.
And we have more coming up this week. We've got more webinars, and we also have a webinar next week, not specifically about coding, but sort of an application of coding. We're going to be talking about autonomous vehicles with a researcher from Carleton University. So you can find more information about any of these upcoming webinars and our other educational programs at pirweb.org. Thanks so much for tuning in today, everyone, and happy Hour of Code.